Hello students. Today's first question is, if A, B, C, D, B, A and D, C are two-digit numbers, then the maximum value of AB into CD minus BA into DC, where A, B, C, D are distinct non-zero integers. So we have been given that A, B, C, D are distinct and are not equal to 0, right? And are integers, right? Now, AB into, we need to find the maximum value of AB into CD minus BA into DC, right? Now, if I write AB in the standard form, it will be 10A plus B, and this is product. This will be 10C plus D minus 10B plus A into 10D plus C, right? Now we need to find the value of this, the maximum value. Now if I multiply, I will be getting, first I will multiply this with this one, then this one. So 100 AC plus 10 AD plus now 10 BC plus BD, right? Now since all will give me positive terms, so I am opening the brackets also. So this will be 100 BD minus 10B into C minus 10 BC minus 10 AD and minus AC, right? Now you see the like terms. Now here it is 10 AD and 10 AD, so this will get cancelled. Moreover, there it is 10 BC and 10 BC, it will get cancelled. Now 100 AC minus AC will be 99 AC, and here it is BD and minus 100 BD, so this will be minus 99 BD, right? Now taking 99 common, I will be getting AC minus BD. So basically I need to find the maximum value of this, right? Now when can this be maximum? It can be maximum when the product AC is maximum and the product BD is minimum. Now since A, B, C, D are distinct integers and they're not equal to 0, so I can assign the maximum value A and C as 9 and 8. Maximum value 9 into 8, so that means this is equal to 72. And for BD to be minimum, I can assign them value 1 and 2. 1 into 2, so that is 2. So that means basically 99 into AC is, see, if I write the value 0 over, this will become 0, right? So I need to write the maximum value, maximum digits are 9 and 2, 9 and 8, 72 minus BD is 2. So this is basically 99 multiplied by 70. So that means any number which will be having 0 at is unit digit. So that is only option C. We will check by multiplying. So after multiplying we get 6930. So right option is option C. In how many ways 12,600 can be expressed as a product of two factors which are relatively prime? So for this we need to prime factorize this. I can write this as 126 into 100 and 126 into, this is 10 square, or I can write this as 2 into 5 whole square into 126. So this will be into 2 square into 5 square, right? Now 126, I will prime factorize 126, 2, 6, 3, 7, 9, 3, 3. So basically it is equal to 126 is 2 into 3 square into 7. So I will write this, and 2 this will become 2 cube, then 3 square, then 5 square and 7. So this is the prime factorization of 12600. Now in order to find the two factors, product of two factors which are relatively prime, we have a formula, and that is 2 raised to power n minus 1, where n is equal to, n is the number of prime factors in its prime factorization. Okay? Prime factors in its prime factorization. So we have 2, 3, 5, 7, 4 prime factors. So I will write 2 raised to power 4 minus 1, which is equal to 2 raised to power 3, which is equal to 8. So it can be represented as a product of two factors which are relatively prime in 8 ways, right? So right option will be option number C, the right answer. The number of zeros at the end of 2 raised to power, so this whole expression, so first of all I will write the expression 2 raised to power 123 minus 2 raised to power 122 minus 2 raised to power 121. This whole expression is multiplied by 3 raised to power 234 minus 3 raised to power 233 minus 3 raised to power 232. So I have told you in the previous video also that the number of zeros basically means 10, and this will depend upon 2 into 5 and minimum power. So minimum power out of 2 and 5 will be the number of zeros, right? Now here I can take 2 raised to power 121 common, so I would be left here with 2 square, right? When you multiply it, you will get 2 raised to power 123 again. Here I will be left with 2, and here since I have taken the whole common, so I will be left with 1. Now over here minimum power is 3 raised to power 232, so I will take 2 raised to power 32 common, and I would be left with here 3 raised to power 2 minus 3 and minus 1. Now 2 raised to power 121, 2 raised to power 2 square is 4, 4 minus 3, so this will be 1, multiplied by 3 raised to power 232 into 9 minus 4, right? So this will be 2 raised to power 121 multiplied by 3 raised to power 232 multiplied by 5. Now you see the minimum power of, we have 2 how many times? 121 times, but that can't yield us 10 unless and until we have 5, but we have 5 only 1, so we can say that number of zeros will be only 1. Number of zeros will be 1. So right option for this question will be option number B, only 1 0. Right option, option number B. If the sum of two numbers added to their squares is 42 and the product of these numbers is 15, then the numbers are. So we need to find the value where the sum of two numbers added to sum of their squares is 42, right? So let us suppose the numbers be A, B, numbers be A and B. So we need to find the numbers where the given condition is A plus B plus A square plus B square should be equal to 42 and AB should be equal to 15. Now we will check for each options. Now these two options B and C, one number in this is in the form of fraction. So we'll deal with this later. First we'll find for option A. Option A, product 15 into 1 is 15. So this satisfies this condition. But as you see, the sum is 42 and the square of 15 is 2 to 5. So this sum will be far more greater than this. So we'll cancel this option. Now we'll look for option D first and then we will look for option B and C. Now product is again 5 into 3, 15. Now addition, 5 plus 3 plus 25 plus 9. So this is 8, 8 and 9, 17, 79, 25 is 42. So we are getting both the conditions satisfied. So we'll say the option D is the right option. Right? If you want, you can check for option B and C also. And the right option is option D. If x is a natural number which is a perfect square, then the number x plus under root of x must end in. So we need to find x is, we have been given that x is a natural number which is a perfect square. So the value of x can be 1, 2 and 3, they are not perfect square, 4, and then is 9, then is 16, 25, 36, 49, 64, 81 and so on. Now we will check for x plus under root of x. Now for 1 it will be 1 plus under root of 1, so that will end with 2. Now for the second 4 plus under root of 4, so this is 6. 16 plus under root of 16, so this will end with 16 plus 4, 20. Right? No, sorry, we have left one 9, so 9 plus under root of 9, so this will end with 9 plus 3, 12. Now we just need to find the unit digit, so this is 2, then 6, 0, again 2. Right? Now moving further for 25, 25 plus under root of 25, so this is 25 plus 5, so that is basically 30. Now this is ending with 0 also, Next is 36 plus under root of 36. So this will be 36 plus 6, which is equal to 42, again 2. Now for 7, 49 plus under root of 49. So this will be 49 plus 7, so that is 56. Now this is ending with 6. Now check for some more examples. 64 plus under root of 64. So this is 64 plus 8, which is equal to 72. Unit digit is 2. Again, it is in this category. Now for 81, it will be 81 plus under root of 81. So that will be 81 plus 9, 90. So unit digit is 0. So we can say overall that the unit digit must end in 2, 6 or 0. So right option will be option number C, 0 or 2 or 6. So right option will be option number C. If x is equal to 2 raised to power 1 by 3 into plus 2 raised to power minus 1 by 3. So x is basically equal to 2 raised to power 1 by 3 plus 2 raised to power minus 1 by 3. Then the value of 2x cube minus 6x. So basically this is, if I take 2 common, this will be x cube minus 3x. Right? Now first I need to find x cube. So x cube is cubing, I will get this whole cube. So this will be 2 raised to power 1 by 3 plus 2 raised to power minus 1 by 3 whole raised to power 3. Now this is a plus b whole cube. So a plus b whole cube. Now this is equal to a cube plus b cube plus 3ab into a plus b. So this will be equal to 2 raised to power 1 by 3 into 3. So 3 and 3 will get cancelled. Plus 2 raised to power minus 1 by 3 into 3. So this will be 3 into 3 can get cancelled. Plus 3 dot 2 raised to power 1 by 3 multiplied by 2 raised to power minus 1 by 3 into 2 raised to power 1 by 3 plus 2 raised to power minus 1 by 3. Now this gives me 2 plus 2 raised to power minus 1. So this is basically 1 by 2 plus. Now this will get cancelled because 2 raised to power 1 by 3. This will go to denominator and gets cancelled. Now I am left with 3 dot. Now this expression is equal to x. So I will write x. Basically this is equal to taking LCM. So this will be 5 by 2 plus 3x. Now x cube minus 3x will be equal to, this is x cube. This is the value of x cube. So first of all I will find the value of x cube minus 3x. In that case this 3x will get cancelled. So I would be left with 5 by 2. I need to find the value of whole expression. So I will multiply 2 into 5 by 2. 2 gets cancelled. The value is 5. So right option will be option number A plus 5. If 2s is equal to a plus b plus c. So 2s is equal to a plus b plus c. Then the value of s minus a whole square plus s minus b whole square plus s minus c whole square plus s square minus a square minus b square minus c square will be. So first we will open these brackets. So this is basically a minus b whole square, which is equal to a square plus b square minus 2ab. So this will be equal to s square plus a square minus 2as plus s square plus b square minus 2bs plus s square plus c square minus 2sc plus s square minus a square minus b square minus c square. Right? Now s how many times? 1, 2, s square, 3, 4. So I will write 4s square. Right? Now here it is a square, here it is minus a square, so this will get cancelled. B square minus b square, so this will get cancelled. C square and minus c square will get cancelled. Now I am left with minus of 2as, minus of 2as, minus of 2bs and minus of 2sc. So this will be minus of 2as, minus 2bs and minus 2sc. Right? Now I can take 2s common. So I will be left with a plus b plus c, as I have taken minus also common. Right? Now a plus b plus c is equal to, which we have been given, 2s. So I can write this expression as 4s square minus 2s multiplied by 2s, substituting a plus b plus c with 2s. Now 2s into 2s is 4s square. So this is basically 4s square minus 4s square, which is equal to 0. So So right option for this question will be option number D, 0. X is a 5-digit number. The digit in 10,000 place is 1. So in all the options, the unit at the unit, tens, 100,000, 10,000 place, all the options are having 10,000 place as 1. The number found by its digits in units and tens place is divisible by 4. So that means first two digits are divisible by 4. So 20 is divisible, 20 is divisible, 60 is also divisible, 80 is also. Both the conditions are satisfied by all the 4 options. Now further moving, the sum of all the digits is divisible by 3. For now, we will check for all those options. Option A is 14020. So this is basically 4 plus 2, 6 plus 7. So this is not divisible. So option A is out of the, this is not divisible by 3. Now for option B. Option B is 12060. So yes, 6 plus 2 plus 1, 3. So this is divisible by 3. Divisible by 3. Option C, 10020. So sum of digits is 3. So this is divisible by 3. Option D, 100. So sum of digits is divisible by 3. So this is also an option. Now further moving, if 5 and 7 also divide x, then x will be, now 5 and 7. So you see 5 is dividing all these 3 options. Now we'll check for, so basically the question boils down to which of these 3 numbers is divisible by 7. So we'll check for 12060, then we will have to check for 10020, and then last 10080, divisibility check for 7. Right? Now if I check for first 12060, so this will yield me 1, leaving 5 remainder, then 7, 16, 2, and then it is 20. So this is not divisible. So option B is out of question. Now moving to option C. So this will give me 1, 3 remainder 30. So 4, 22, 3, 21, 10. So this is also not divisible. So right option for us will be, since only one option is left, so option D. So we'll check further. 7, 1, 7, 30, 4, 22, 28, 4 and 0. So right option is option number D, which is satisfying all the conditions. The least number which when divided by 2, 3, 4, 5 and 6 leaves the remainder 1 in each case. If the same number is divided by 7, it leaves no remainder. The number is no. So first of all we need to find the LCM of 2, 3, 4, 5 and 6. Right? So 2, 3, 4, 5, 6. Dividing with 2, 1, 3, 2, 5, 3. Again with 2, 1, 3, 1, 5, 3. Now with 3, 1, 1, 1, 5, 1. So 5 into 3, 15 into 2, 30 into 2, 60. So LCM of these numbers is 60. Now this number when divided by all these numbers will give me remainder 0. Right? So the number for this number I must add 1. So that will be 60 plus 1 and multiple of this. But there is one more condition, that it must be divided by 7 and leave no remainder. So that means 60, let us suppose this number k plus 1 should be divided by 7. So this is what we need to find for the minimum value of. So minimum value of k is 1, and for that 61 by 7. So this is not divisible by 7. Okay? Now with value k equal to 2. So this will be equal to 121. Now 121 divided by 7. So 7, 151. So this is also not divisible for value of k equal to 3. So that will be 181. Now 181 divided by 7. So 7, 2, 14 and 41. So this is also not divisible for value of k equal to 4. So this will be 241 divided by 7. So this will be 7, 3, 21, 31. So this is also not divisible. Now for value of k equal to 5. So this will be 301 divided by 7. So this will be giving us 7, 4, 28 and then 21. Yes, this is divisible. So the number is 301. We'll look for options. Yes, there is an option number B. Right? So this is the right answer. Now you can check. If you divide by 2, it will give me a remainder 1. If you divide by 3, 300 is divisible. It will give me 1 remainder. For 4 also, for 5 also and 6 also. But it is divisible by 7. So right option will be option number B. If x raised to power x raised multiplied by under root of x is equal to x multiplied by under root of x whole raised to power x, then the value of x is. So basically we need to find the value of x. The expression given is x raised to power x multiplied by, so root x I can write x raised to power 1 by 2. This is equal to, now opening the brackets, we know that if we have been given that ab raised to power m, so this is equal to a raised to power m and b raised to power m. So this will be equal to x raised to power x dot x raised to power 1 by 2 into x, right? Now this is same powers added, so I can write x raised to power 1 plus 1 by 2, which is equal to 3 by 2, and this is equal to, now again base is same, powers added, right? Now x plus 1 by 2x, so if I take x common, so this will be equal to 3 by 2 of x. Now in equality bases are same, now powers can be equated, so I can write x raised to power 3 by 2 should be equal to 3 by 2 of x, right? Now if I shift this x to this side, so this will be equal to x raised to power 3 by 2 upon x equal to 3 by 2. So this is basically equal to x raised to power 3 by 2 minus 1 equal to 3 by 2, which gives me 3 minus 2, so this is basically 1 by 2 equal to 3 by 2. So under root of x is equal to 3 by 2, which implies if I square both sides, I will be getting the value of x equal to 9 by 4. So right option for this question will be option number A, 9 by 4. If 2s is equal to 9, so we have been given that the value of twice of s is equal to 9, then the value of s square plus s minus 1 whole square plus s minus 3 whole square plus s minus 5 whole square is, now we'll open the brackets, s square, so this is a minus b whole square, a square plus b square plus, sorry, minus 2ab, so this will be minus 2s plus s square plus 9 minus 2 into 3, 6x plus s square plus 25 minus 10s. Now how many s square are there? 1, 2, 3 and 4. So 4s square, then minus 2s, minus 6x, minus 8s and minus 10s. So this is minus 18s, right? Plus 1 plus 9, 10, 10 plus 25, 35. So we have been given this. Now from this 2s is equal to 9, I can have s is equal to 9 by 2, right? Now putting this value over here, so this will be 4 dot s square, so this will be 81.4 minus 18 dot 9 by 2 plus 35. Now 4 and 4 gets cancelled, 2 and 9. So this is 81, 9 into 9 is also 81, so this will be 81 minus 81 plus 35, right? So 81 gets cancelled, you are left with 35. So right option for this will be option number D. In a nationwide smart city business idea hunt, the jury selected total 100 proposals from 6 cities: Bengaluru, Mumbai, Delhi, Hyderabad, Chennai and Pune. Bengaluru outsmarted all other cities by getting accepted 50 proposals alone from it. Pune stood last as only 5 proposals were selected from this city. So to this we will try to manipulate the data. So Bengaluru stood at the first place and Pune at the last, right? Pune had 50 proposals and, sorry, Bangalore and Pune had 5. And the total number of proposals are 100. Now, the second highest number of proposals was selected from Mumbai. So this is, if this is the order, so here it is Mumbai. What is the minimum number of proposals that would have been selected from Mumbai if distinct number of proposals were selected from each of these cities? So we can have others in this area because Pune got the lowest. So in any order, Delhi, Hyderabad, Chennai, right? So Mumbai has to be at the second, right? Now the question is minimum number of proposals Mumbai had, right? This is a question, we need to find that. Now since 55 proposals have been given from Bangalore and Pune alone, so M plus D plus H plus C should be equal to the total number of proposals, which are 100 minus 55, 45, right? Total number of proposals were 100 and Bangalore and Pune are giving 55 proposals, so 100 minus 55. So this means the total number of proposals given by these 4 cities, Mumbai, Delhi, Hyderabad and Chennai should be 45. Now, we know that M must be greater than D, H, C because it is at the second number, right? Now, all these are distinct because it has been given that if distinct number of proposals were selected from each cities. Now, 45, if I divide 45 by 4, so this will be equal to 11.25, right? Now, the greatest integer from above this is 12. So, let us suppose we give allot 12 proposals to Mumbai, right? In that case, Delhi will have 11, Hyderabad can have 10 and 9. So, this is 19, 19 and 11, 30, 30 into 44, 42. So, this is not adding to the total. No. If we increase and get 13 for Mumbai, so 12, 11 and 10. So, 13 plus 12, 25, 25 plus 10, 35, 35 plus 11, 46. So, now, since these are increasing, we can change any of these values. We can have here 11, we can have here 10, we can have here 9, or we can have any of the options over here. But minimum number of proposals which Mumbai can have is 13 because we found that if we allot 12 proposals to this, right? In that case, the sum comes out to be less than 45, right? So the minimum number of proposals Mumbai can have is option D is the right answer, right? Because we have to keep in mind that Mumbai should have more number of proposals than Delhi, either Delhi, Hyderabad or Chennai, right? Now, if this question comes in a way that you have to find the maximum number of proposals Mumbai can have, right? And it has to be at the second number, so it has to be less than 50, so total has to be 45. In that case, if I allot 42 to Mumbai, then I can allot to Delhi 1. Since these need to be distinct, so I can allot this to 2, so 42 plus 3, 45, so Chennai should have some proposals, so again 41, then 3 plus 2 plus 1, so this is 3 to 5 and 6, so this is greater than that, so 40 plus 3 plus 2 plus 1, so that is also greater than this, so 39 plus 3 plus 2 plus 1, so this will be equal to 42, 44, 45. So in that case, maximum number of proposals Mumbai can have is 39, right? Because this has to be distinct. But in this case, Pune is having 5, so it is at the lowest. So I can't allot these 3 to 1 to this. So that is also not a possibility. So in that case, I have to be rewrite and 35, and this has to be greater than this 5. So 6, 7, 8. So this is basically 8, 7, 15, 21. So 21 should be allotted to this, and if I subtract, so this will be 24. So 24 maximum can be allotted to this. In that case, it can be 24, and then I can have 8, 7, 6 in this order for finding the maximum number of proposals, right? So this is when this kind of question comes. Here we have been asked to find minimum number of proposals. So minimum number of proposals we can have is 30. Option D is the right answer, not 12, because when we give 12 to this will not add up to 45. For any natural number n, if Dn is the sum of all the digits of Dn, find the remainder when summation 1 to 99 Dn is divided by 99. So basically this question says that numbers from 1, 2, 3, 4, so on up to 99. Right? So yes, the sum of digits, so basically up to 9 plus 9 and then plus 10, 11, the sum of digits. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Then is 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19, right? Now, if I look for digit 1, so here it is also there. So now here 11, then in 21, 31, 41, 51, 61, 71, 81 and 91. And here also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, right? So here in 11 it is in 2 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 1 is 20 times. Now in order to generalize, I will check for one more digit. So if I write over here, so this will be 22, 23, 24, 25, 26, right? Sorry, 22, then 32, then 42, then 52, then 62, then 72, 82 and 92. Now we'll check for digit 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And from here 23, 24, 25, 26, 27, 28 and 29. So 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 2 is also represented 20 times. So basically I am trying to tell you that up to 1 to 99, all these digits are repeated 20 times, right? So basically this is equal to, the sum is equal to 120 times 1 plus 2 plus 3 plus so on up to plus 9, right? If you want, you can check for other numbers, other digits also. Every digit is appearing 20 times, right? Now this is the sum of first 9 natural numbers. So this is equal to n into n plus 1 by 2. So this is equal to 20 into n is 9 into 10 divided by 2. So this is 5. So 20 into 45, right? Now 45 into 10 is 450. So this sum adds up to 99. Now question is when it is divided by 99, what is the remainder? So when I divide this by 99, what will be the remainder? Now 99 into 10 is 990. So 99 into 9. So this will be 1, 8, 99, 81 and 8, 89. So 890. So 99 into 9 is equal to 891. So when I divide this by this, so the remainder left will be 9. So right option will be option number A. In Mahabalipuram temple, there are some magical bells which toll 18 times a day simultaneously. But every bell tolls at a different interval of time, but not in fraction of minutes. So that means it is in fraction of minutes, not in, this is an integer. The maximum number of bells in the temple can be. So basically there are, let us suppose, n number of bells, right? Now these bells ring at their individual time, right? But they bell simultaneously 18 times a day. So that means there are 24 hours dividing by 18. So this will be equal to 24. So this will be 4 divided by 3, right? Now 4 divided by 3 into 60. So this will be 20. So 80 minutes. So every 80 minutes these n number of bells ring simultaneously, right? Now we need to find what can be the maximum number of bells in the temple. Now since they bell every 80 minutes simultaneously, so first of all we will do prime factorization of 80. So 80 is basically equal to 8 into 10, and this is 2 cube into 2 into 5, or I can say 2 raised to power 4 into 5. So the number of factors of this are, total number of factors will be equal to 4 plus 1 into 2, that means 5 into 2, 10. So maximum number of bells can be 10. Or in other ways we can find out of these options which is a factor of 80. So the right option will be option number B. There can be maximum 10 number of bells. If A square plus B square plus C square plus D square is equal to 1. So we have been given that these all squares are equal to 1. Then the maximum value of A multiplied by B multiplied by C multiplied by D. So we need to find the maximum value. Now we know that the maximum value can happen only when these are equal. So I can say that A is equal to B is equal to C is equal to D is equal to, let us say, K. Right? Now this whole square is equal to 1. So that means K square plus K square plus K square plus K square should be equal to 1. This implies 4K square should be equal to 1, or K square should be equal to 1 by 4, or K should be equal to plus minus 1 by 2. Right? Now, we need to find the maximum value of this. So this will be equal to a multiplied by b multiplied by c multiplied by d. So that basically means k raised to power 4. Right? So that is basically this. The value of k is plus minus 1 by 2 whole raised to power 4. So since the power is even, so both positive as well as negative 1 by 2 will yield be positive. So this is equal to 1 by 16. So the maximum value of a into b into c into d is 1 by 16. So right option will be option number C. The value of n in the expression n square minus 2n factorial plus n is equal to 0 for every n which belongs to natural numbers is. So we need to find the value of n. N is a natural number and the expression which it satisfies is n square minus 2n factorial plus n equal to 0. So this is basically n square plus n should be equal to twice of n factorial. If I take n common, so n into n plus 1 should be equal to twice n factorial. Right? Now we will see for each value. Now options A is 6. So if I put the value of n equal to 6, so this is 6 into 7 should be equal to 6 into 5 into 4 into 3 into 2 into 1 multiplied by 2. So this is not equal because this multiplication will be much greater. So option A is not the right choice. Option B, n is value 1. So this is 1 multiplied by 2. On the right side it will be 2 into 1 factorial. So this is also 2. So this is right option. Option C, 3. So n value 3. So that means 3 into 4. On the right side it will be 2 into 3 factorial. Now this is equal to 12 and on the right side it is 2 into 3 into 2. So this is also 12. So option C is also right. So we can say both B and C are true. Option D is the right answer. The value of n factorial whole raised to power n. If n plus n minus 1 plus n minus 2 is equal to n into n minus 1 into n minus 2, where n cube is greater than 9. So we need to find the value of n factorial whole raised to power n. And we have been given that n cube is greater than n and it is a positive number. Now n plus n minus 1 plus n minus 2 is equal to n into n minus 1 into n minus 2. Now this is n plus n 3n minus 1 minus 2 3n minus 3. This is equal to n into n minus 1 into n minus 2. Right? Now if I take 3 common, so I will be left with n minus 1, n into n minus 1 into n minus 2. So n minus 1 gets cancelled. N into n minus 2 is equal to 3. So this is n square minus 2n minus 3 equal to 0. So this is a quadratic equation. Now splitting the middle term, product I need to be minus 3 and sum equal to minus 2. So this will be n square minus 3n plus n minus 3 equal to 0. So minus 3n plus n is minus 2 and minus 3 into plus 1 is minus 3. So now I will take n common, n minus 3 plus 1, n minus 3 equal to 0. n minus 3 common, n plus 1 equal to 0. So the value of n comes out to be n equal to 3 and minus 1. Now since this is the criteria and n cube for this will be negative, so this value has to be discarded. So n is equal to 3. Right? We need to find the value of 3 factorial whole raised to power 3. So this is 3 into 2. 3 factorial is 3 into 2 into 1 whole raised to power 3. So this is 6 raised to power 3. So this is basically equal to 216. The right option will be option number B. Option number B is the right answer, 216. So thank you for today's lecture. Bye bye. Take care.